NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math video. Today, we'll explore an important factoring technique, the sum of cubes identity. Let's start by understanding the general formula for the sum of cubes. The sum of cubes identity states that a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Let's visualize this with an example. Consider the expression x cubed plus 27. First, we need to identify the values of a and b. Here, a equals x and b equals 3. Now, let's apply the sum of cubes formula to factor this expression. First, we can rewrite x cubed plus 27 as x cubed plus 3 cubed. Next, using our formula, we get x plus 3 times the expression x squared minus x times 3 plus 3 squared. Simplifying further, we get x plus 3 times x squared minus 3x plus 9. We need to factorize 8 a cubed plus b cubed. First, let's rewrite this in a form where we can apply our sum of cubes formula. We can rewrite 8 a cubed as open parenthesis 2 a close parenthesis cubed. Now we can apply our formula for the sum of cubes. The formula states that a cubed plus b cubed equals open parenthesis, a plus b close parenthesis times open parenthesis a squared minus ab plus b squared close parenthesis. Let's substitute our values into this formula. In our case, at equals 2, a, and b equals b. So we get open parenthesis 2 a plus b close parenthesis times open parenthesis 2 a close parenthesis squared minus open parenthesis 2 a close parenthesis times b plus b squared close parenthesis. Now, let's simplify the expression inside the square brackets. Open parenthesis 2 a close parenthesis squared equals 4 squared. And open parenthesis 2 a close parenthesis times b equals 2ab. So our expression becomes open parenthesis 2 a plus b close parenthesis times open parenthesis 4 squared minus 2a b plus b squared close parenthesis. So we've successfully factored our original expression. 8 a cubed plus b cubed equals open parenthesis 2 a plus b close parenthesis times open parenthesis 4 squared minus 2a b plus b squared close parenthesis. Let's move on to our second example. Here, we need to factorize a cubed plus 125. First, we need to rewrite this in a form where we can apply our sum of cubes formula. We can rewrite 125 as 5 cubed. Now we can apply our formula for the sum of cubes again. In this case, at equals a and b equals 5. Now let's simplify the expression inside the brackets. A times 5 equals 5a, and 5 squared equals 25. So our expression becomes open parenthesis, a plus 5 close parenthesis times open parenthesis, a squared minus 5, a plus 25 close parenthesis. So we've successfully factored our second example. A cubed plus 125 equals open parenthesis, a plus 5 close parenthesis times open parenthesis, a squared minus 5, a plus 25 close parenthesis. Before we start solving examples, let's look at the formula we'll be using. The sum of cubes formula states that a cubed plus b cubed equals the product of a plus b and a squared minus a times b plus b squared. This formula is incredibly useful for factoring expressions that look like a sum of cubes. Let's begin with our first example. We need to factor x cubed plus 8. To use our formula, we need to identify what a and b are in this expression. For x cubed, it is simply x. For 8, we need to recognize that 8 is 2 cubed, so b equals 2. Now, let's apply our formula. We know that a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Let's simplify this further. We have x plus 2 times x squared minus 2x plus 4. This gives us our factored form of x cubed plus 8. Now, let's move on to our second example. We need to factor x cubed plus 1. Again, we need to identify a and b. Here, a is x, and b is 1, since 1 cubed is 1. Using our formula, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Let's simplify this expression. We have x plus 1 times x squared minus x plus 1. This gives us our factored form of x cubed plus 1. A cubed plus 8b cubed. We can identify that this is the sum of two cubes, where the first term is a cubed and the second term is 8b cubed. So the second term can be rewritten as 8b cubed equals 2b to the power of 3. Let's apply the formula for the sum of cubes. We substitute a equals a and b equals 2b into our formula. This gives us a plus 2b times a squared minus a times 2b plus 2b squared. Let's simplify. A plus 2b times a squared minus 2 a plus 4b squared. Now, let's move to our second example. B cubed plus 8 over 27. Again, we need to identify that this is a sum of cubes. The second term can be rewritten as 8 over 27 equals 2 over 3 to the power of 3. We'll apply the same formula for the sum of cubes. Here, we substitute a equals b, and b equals 2 over 3. This gives us b plus 2 over 3 times b squared minus b times 2 over 3 plus 2 over 3 squared. Let's simplify. B plus 2 over 3 times b squared minus 2b over 3 plus 4 over 9. Let's summarize what we've learned. To factor the sum of cubes, we use the formula. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Let's look at our example. We need to factorize x to the power of 9 plus 1. First, we notice that 9 equals 3 times 3. This allows us to rewrite x to the power of 9 as x to the power of 3 to the power of 3. So our expression becomes x to the power of 3 to the power of 3 plus 1 to the power of 3. Now we can apply the formula for the sum of cubes, which states that a cubed plus b cubed equals a plus b times a squared minus a times b plus b squared. In our case, a is x to the power of 3 and b is 1. Let's simplify the expression. We have x to the power of 3 plus 1 times the quantity x to the power of 3 squared minus x to the power of 3 times 1 plus 1 squared. This simplifies to x to the power of 3 plus 1 times x to the power of 6 minus x to the power of 3 plus 1. Now we need to factorize x to the power of 3 plus 1. We can use the formula a plus b equals a plus b times a squared minus ab plus b squared. In this case, a is x and b is 1. Now we can rearrange the brackets to get the final factorization. We have x plus 1 times x squared minus x plus 1 times x to the power of 6 minus x to the power of 3 plus 1. Therefore, the complete factorization of x to the power of 9 plus 1 is x plus 1 times x squared minus x plus 1 times x to the power of 6 minus x to the power of 3 plus 1. This is our final answer. We want to factor the expression x to the power of 5 minus 1 minus x squared times quantity x minus 1. We'll start by expanding the expression. First, let's distribute x squared into the parenthesis containing x minus 1. Now, let's rearrange this expression to group terms by their powers. We have x to the power of 5 minus x cubed plus x squared minus 1. For our next step, let's rearrange the terms to help with factorization. We'll group x to the 5th power minus x cubed in one group and x squared minus 1 in another. Now, we can factor out common factors from each group. From the first group, we can factor out x cubed, leaving us with x squared minus 1. We now have x cubed times the quantity x squared minus 1 plus the quantity x squared minus 1. Now we can factor out the common factor x squared minus 1 from the entire expression. This gives us the quantity x squared minus 1 times the quantity x cubed plus 1. Let's factor x squared minus 1 further. This is a difference of squares, which can be factored as quantity x minus 1 times quantity x plus 1. For our final step with this example, we need to apply the sum of cubes formula to factor x cubed plus 1. According to the formula, we can rewrite the factor as quantity x plus 1 times quantity x squared minus x plus 1. Let's move on to our second example, x to the power of 7 plus x to the power of 4 minus 16 x cubed minus 16. For this problem, we'll start by grouping terms to help with factorization. Let's group x to the power of 7 and negative 16 x cubed together, and similarly group x to the power of 4 and negative 16 together. Now, let's factor out common terms from each group. From the first group, we can factor out x cubed, giving us x cubed times quantity x to the power of 4 minus 16. The second group can be written as x to the power of 4 minus 16. Now we can factor out the common factor x to the power of 4 minus 16 from the entire expression. This gives us the quantity x to the power of 4 minus 16 times the quantity x cubed plus 1. The factor x to the power of 4 minus 16 can be further factored as a difference of squares. X to the power of 4 is equal to quantity x squared squared, and 16 is equal to 4 squared. So we can factor this as quantity x squared plus 4 times quantity x squared minus 4. Let's factor x squared minus 4 further as another difference of squares. This gives us quantity x plus 2 times quantity x minus 2. Finally, we can apply the sum of cubes formula to factor x cubed plus 1, just like we did in the previous example. X cubed plus 1 equals quantity x plus 1 times quantity x squared minus x plus 1. We need to factor the expression 8a cubed plus b cubed minus 4a squared b minus 2ab squared. Let's first rearrange the expression to make it easier to work with. We can rewrite this as open parenthesis 8a cubed plus b cubed close parenthesis minus 2, b times open parenthesis 2 plus b close parenthesis. Now we can apply the sum of cubes formula. The sum of cubes formula states that a cubed plus b cubed equals open parenthesis, a plus b close parenthesis times open parenthesis a squared minus a b plus b squared close parenthesis. In our expression, we have 8a cubed plus b cubed, which means it equals to a, and b equals b. Let's substitute these into the sum of cubes formula. Now, applying the sum of cubes formula, we get open bracket open parenthesis 2 a plus b close parenthesis times open parenthesis for a squared minus 2, a b plus b squared close parenthesis close bracket minus 2, a b times open parenthesis 2 a plus b close parenthesis. We can see that open parenthesis 2 a plus b close parenthesis is a common factor. Let's factor it out, giving us open parenthesis 2 a plus b close parenthesis times open bracket open parenthesis for a squared minus 2, a b plus b squared close parenthesis minus 2, a b close bracket. Let's simplify the expression inside the square brackets. We get 4a squared minus 2ab plus b squared minus 2ab, which simplifies to 4a squared minus 4ab plus b squared. Now we need to factor the quadratic expression in the brackets. We can rewrite 4a squared minus 4ab plus b squared as open parenthesis 2 a minus b close parenthesis squared. Our final factorization is open parenthesis 2 a plus b close parenthesis times 4 times open parenthesis a minus b over 2 close parenthesis squared, which can be written as open parenthesis 2 a plus b close parenthesis times open parenthesis 2 a plus b close parenthesis times open parenthesis 2 a minus b close parenthesis times open parenthesis 2 a minus b close parenthesis. Let's move on to our second example. We need to factor the expression a cubed plus b cubed minus a squared plus a b minus b squared. Let's first rearrange the terms to make it easier to spot patterns. We can rewrite this as open parenthesis a cubed plus b cubed close parenthesis minus open parenthesis a squared minus a b plus b squared close parenthesis. Now we recognize that the first part, a cubed plus b cubed, can be factored using the sum of cubes formula. This gives us open parenthesis a plus b close parenthesis times open parenthesis a squared minus a b plus b squared close parenthesis. We notice that open parenthesis a squared minus a b plus b squared close parenthesis appears in both terms. We can factor it out. Let's simplify the bracket. Open parenthesis a squared minus a b plus b squared close parenthesis appears in both terms. We can factor it out. Let's simplify the bracket. Open parenthesis a plus b close parenthesis minus 1 equals a plus b minus 1. So our final factorization is open parenthesis a squared minus a b plus b squared close parenthesis times open parenthesis a plus b minus 1 close parenthesis. Let's summarize what we learned about factoring polynomials with multiple variables. We saw that recognizing patterns and special factoring formulas is key to success. The sum of cubes formula, a cubed plus b cubed equals open parenthesis, a plus b close parenthesis times open parenthesis, a squared minus, ab plus b squared. We're going to factorize the expression x cubed plus y cubed minus x squared, y minus x, y squared minus x minus y. This expression looks quite complex, but we'll break it down systematically. Step 1. Let's first group similar terms. We'll rewrite the expression as the sum of x cubed plus y cubed plus the sum of negative x squared, y minus xy squared, plus the sum of negative x minus y. Step 2. Now, let's apply the formula for the sum of cubes. We know that a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Using this formula for the first group, we get x plus y times x squared minus xy plus y squared. Step 3. Let's focus on the middle group. We can factor out negative xy from the terms negative x squared y minus xy squared, giving us negative xy times x plus y. Step 4. For the last group, we can factor out negative 1. Negative x minus y becomes negative 1 times x plus y. Step 5. Now that we have a common factor of x plus y, in all three groups, we can factor it out from the entire expression. This gives us x plus y times x squared minus x, y plus y squared minus x, y minus 1. Step 6. Let's simplify the expression in the second bracket. We can combine like terms. Negative xy appears twice, so we get negative 2xy. So our expression becomes x plus y times x squared plus y squared minus 2x, y minus 1. Step 7. We can further simplify the second bracket by recognizing that x squared plus y squared minus 2x, y is the expansion of x minus y squared. Using the formula for the difference of squares, a squared minus b squared equals a plus b, a minus b, we can rewrite x squared plus y squared minus 2x, y minus 1 as x minus y squared minus 1. Step 8. Now we can apply the difference of squares formula to the term x minus y squared minus 1. Using a squared minus b squared equals a plus b, a minus b, where it is x minus y, and b is 1. This gives us x plus y times x minus y plus 1 times x minus y minus 1. Step 9. Let's simplify x minus y plus 1 and x minus y minus 1. X minus y plus 1 equals x minus y plus 1, which is x minus y plus 1. And x minus y minus 1 equals x minus y minus 1, which is x minus y minus 1. So our final factorization for the first example is x plus y times x minus y plus 1 times x minus y minus 1. This is the complete factorization of the original expression. Now, let's move on to our second example. We're going to factorize the expression 8 to the power of n plus 1. Step 1. Let's rewrite 8 to the power of n in terms of 2. Since 8 equals 2 to the power of 3, 8 to the power of n equals 2 to the power of 3 to the power of n, which equals 2 to the power of 3n. Step 2. Let's rewrite our expression to match the standard form. We can see that our expression is of the form a to the power of n plus 1, where it is 2 to the power of 3, or 8. Step 3. Now we can apply the sum of cubes formula. Remember that a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.